On to some common chelating agents. I'm going to point out 4 different types of ligands that bond multiple times to a transition metal cation. First, our point of reference will be a monodentate ligand. Monodentate means that it binds one time to the metal cation. And you know this one, you've seen it already, amine. Some ligands have abbreviations. Amine does not, and its formula is NH3. Bidentate ligands means that a bidentate ligand is a ligand that can bind 2 times to a transition metal cation. So the example that I'm going to show you is ethylene diamine. It also has another name, 1,2-ethane diamine. Its abbreviation is EN. So if you see EN in the formula of a compound, that means ethylene diamine. And the formula of EN is NH2, CH2, CH2, NH2. There are 2 nitrogens, and each nitrogen can bond to the metal cation. We also have a tridentate ligand. That means the ligand has 3 atoms that can coordinate to the transition metal cation. The common name of the tridentate ligand is diethylene triamine. Its systematic name is 2,2'-diamino-diethylamine. Its abbreviation is DIEN, and its formula is NH2, CH2, NH, CH2, NH2. Finally, we have a hexadentate ligand, a ligand that can bond 6 times through 6 different atoms to a transition metal cation. Its IUPAC name, or systematic name I should say, is 1,2-ethane dinitrile tetraaceto. The common name, though, is ethylene diamine tetraacetate, or EDTA. Let me show you that EDTA is truly hexadentate. This is the Lewis structure for EDTA. If you look at the end of these chains, you have oxygens, and the oxygens can bond to the metal cation. So you have 4 different spots on EDTA that can bond. You also have the 2 nitrogens in the middle that have lone pairs of electrons on them that can bond to a transition metal cation. Therefore, only one of the oxygens on an end can bind, because though not both can, and I'll explain why later. But there's 1, 2, 3, 4 oxygens that will bond, and 1, 2 nitrogens that will bond, making EDTA a 6-coordinate ligand. So let me show you how it bonds. So here's the Lewis structure for EDTA, and if we draw it using lines to represent carbon and hydrogen, this is the line structure for EDTA. Remember, the 2 nitrogens can bond, and the oxygens right here, when they lose their hydrogens, can also bond to CO. If you look at this, CO has 1, 2, 3, 4, 5, 6 atoms from EDTA binding to it. EDTA is a hexadentate ligand. You are responsible for knowing the names of the ligands, and on Tuesday we will work on examples together in class to make sure that you know how to systematically name these compounds.